General purpose bucket. The general purpose bucket is the reason a tractor became a lifting machine rather than just a pulling one. A standard 72-inch utility bucket holds 0.75 cubic yards of topsoil, which weighs around 2,000 pounds. Moving that same volume by hand requires approximately 450 individual shovel loads. The curved moldboard at the back of the shell is not structural decoration. It rolls material inward as the cutting edge enters a pile, reducing the force required for penetration and ensuring a full load with each pass. Modern buckets include a float valve circuit that allows the bucket to follow ground contours under its own weight without the operator applying downward hydraulic pressure, which is what makes it useful for spreading gravel without gouging the base beneath. Carl Ragnar Astrom adapted the front loader concept for farm use in the early 1950s, and the 1958 Quick system introduced the first drive-in loader that could be detached and swapped, freeing the tractor for field work between jobs. Before the front loader existed, a family farm had no affordable way to move serious quantities of soil or manure without dedicated earth-moving equipment that most operations could not justify. The general purpose bucket changed that calculation entirely and established the quick attach interface that every attachment on this list depends on. Round bale spear. The round bale spear is the simplest attachment on a tractor and one of the most consequential in the history of livestock farming. It is a tapered steel spike, between 36 and 49 inches long and up to 1.75 inches in diameter, driven directly into the compressed core of a round bale. Two shorter stabilizer spears sit below the main tine. Without them, a bale on a single spike acts as a pendulum at elevation, and a sharp turn, with 2,000 pounds suspended 10 feet in the air, generates enough lateral force to overturn a compact tractor. The attachment exists because of a handling crisis, created in 1966, when large round balers began producing bales weighing 1,500 pounds, far beyond what any person could move manually. To handle the same nutritional volume in 50-pound square bales, an operator would manually lift and stack 40 individual units for every single round bale. The spear moves in one pass. The round bale also sheds water naturally due to its shape, which eliminated the need for enclosed haylofts on farms that adopted it. A single operator with a bale spear could manage a herd 5 times larger than what the square bale era made practical. The spear did not make hay handling easier. It made modern livestock operations at scale possible. The 4-in-1 multi-purpose bucket. The 4-in-1 multi-purpose bucket is the most functionally dense attachment in the front loader category, combining 4 separate machines into one unit through the addition of a single hinge jaw. Edward Drott patented the design in the early 1950s and held exclusive rights for 2 decades. The fixed rear shell and the hinged front jaw are driven by 2 independent hydraulic cylinders, giving the operator a dozer blade with the jaw open flat, a precision grading scraper with the jaw partially open, a grapple clamp for logs and irregular debris, and a standard bucket with the jaw closed. The clamping force reaches 6,000 pounds, enough to crush a heavy-gauge steel drum. Grading a driveway with the scraper mode runs approximately 30% faster than using a rear-mounted blade because the operator faces the work rather than reversing. The serious penalty is weight. A 4-in-1 can weigh twice as much as a standard bucket of identical width. And on a compact tractor, that mass can consume 50% of the loader's rated lift capacity before the bucket holds a single kilogram of material. On professional job sites, where changing attachments costs billable time, the trade-off is worth it. On small farm tractors with modest hydraulic systems, the weight alone can make the attachment counterproductive. Pallet fork carriage. Pallet forks took the logic of the warehouse forklift and moved it into terrain, where a warehouse forklift would sink to its axles. A heavy-duty carriage on a 100-horsepower tractor lifts 4,000 pounds, the equivalent of a fully loaded Ford F-150. The tines are not welded rigid. They float on a rail, hanging vertically even when the tractor sits on uneven ground, which prevents pallets from sliding during entry. Before pallet forks became standard farm equipment, a 1-ton fertilizer delivery arrived as 40 individual bags, requiring manual unloading. With forks, the same ton moves in a single 30-second lift. High-end models include hydraulic tine positioning that adjusts the gap between forks from inside the cab, which matters on a muddy loading dock where dismounting to manually reset tine spacing is both slow and dangerous. The most common dangerous workaround in the category is clamp-on forks, which bolt directly to the lip of a standard bucket. They extend the load center 24 inches past the design point of the bucket, which over time causes loader arm cracking and permanent deformation of the bucket lip. Dedicated fork carriages mount to the quick attach plate and distribute the load correctly. The pallet fork converted the tractor from a machine that handled loose materials into one that could interact with the global standard unit of trade. Root and brush grapple. The root and brush grapple solves a problem that a standard bucket makes worse. A bucket pushed through brush collects soil with the debris, producing piles that are too wet to burn cleanly and too mixed to chip efficiently. The grapple uses a skeleton floor of thick steel tines spaced 6 to 10 inches apart. The debris is grabbed and held while loose soil falls through the gaps, leaving the topsoil in place and producing a clean pile of organic material. Quality units use 2 independent hydraulic lids rather than a single clamping jaw. A log thicker at one end would bridge a single lid and leave the narrower end unsecured. With independent lids, each side clamps until it meets resistance, so irregular and tapered loads are held with equal grip across their full width. The tines also function as a rake when the grapple tilts forward, allowing the operator to drag through the top 6 inches of soil to pull up buried roots. The most consistent source of damage in field use is the hidden obstacle. Tines, designed to penetrate soil regularly, snag buried stumps or large rocks while the tractor is in motion, and the sudden lateral torque transmitted through the loader frame causes twisting on machines, not reinforced for that load path. Economically, the grapple converts land rated as unworkable due to heavy brush into productive pasture, at a fraction of the cost of bringing in a dedicated excavator. Hydraulic tree shear. The hydraulic tree shear is the most powerful cutting tool that mounts to a tractor loader, and it keeps the operator entirely out of the fall zone. A fixed, serrated jaw holds the base of the trunk, while a high carbon steel blade, driven by a large-bore hydraulic cylinder, pulls through the wood. At 5,000 pounds per square inch of operating pressure, the cutting force reaches 132,500 pounds, approximately the gross weight of a Boeing 737, concentrated on a blade less than an inch wide. A 12-inch diameter tree is through in under 5 seconds. The same cut with a chainsaw takes several minutes and carries the risks of bar pinching and kickback on dense or leaning timber. The attachment became essential during the ash borer and pine beetle epidemics across North America, which left millions of standing dead trees too brittle for manual cutters to work near safely. Many models rotate 90 degrees hydraulically, allowing the operator to limb a trunk after felling without repositioning the machine. The primary hazard is the combined weight of the attachment and the tree at the end of the loader arms. Both masses sit well forward of the front axle. On a slope, that forward load shift can exceed the machine's stability threshold. A documented 2001 fatality occurred when this exact sequence caused the loader to tip forward during a cut. Concrete mixing bucket. The concrete mixing bucket turns a tractor into a mobile batch plant. Inside the shell, a horizontal steel auger driven by the tractor's hydraulic system replaces the rotating drum of a conventional mixer. The operator drives the bucket into a pile of aggregate to scoop the raw material, adds water and bagged cement through a grate on top, runs the auger at 20 to 60 rotations per minute to blend the mix, then opens a hydraulic gate and reverses the auger to push the finished concrete out through a side chute. A 1-yard capacity bucket produces enough concrete for a 10-foot by 10-foot slab at 4 inches thick in a single batch. A standard electric drum mixer handles 3 bags in 15 minutes. The loader bucket handles 35 bags in under 5 minutes. The attachment exists because concrete trucks are large, heavy, and frequently unable to reach remote farm locations or tight construction sites without causing ground damage disproportionate to the job. Buying raw materials in bulk and batching on site also eliminates the small load delivery fees that make frequent small concrete pours expensive. The critical maintenance requirement is full washdown immediately after every use. Concrete hardening around the auger bearings is a mechanical failure that is expensive to repair and entirely avoidable. Silage defacer. The silage defacer is a precision dairy farming tool that most people outside the industry have never seen, and its only job is to prevent a tractor bucket from touching silage. Silage is fermented forage packed into bunker silos and sealed under plastic. The chemistry that preserves it is anaerobic. When a standard bucket digs into the pile to feed out, it creates fracture lines that allow oxygen to travel deep into the remaining material, where yeast and mold begin consuming the nutrients before the cattle receive them. The defacer shaves the face instead. A horizontal drum covered in cutting teeth rotates at 150 to 300 revolutions per minute as the tractor raises the loader and draws the drum down the vertical face of the pile. producing a smooth, sealed surface that limits oxygen penetration to the immediate cut area. Reducing oxygen exposure by 3% across the face saves up to 10% of total dry matter from spoilage. For a 500-cow dairy herd consuming 27,500 pounds of silage per day, that percentage translates directly into milk yield per cow and the financial margin of the operation. The fermentation acids inside a bunker silo drive the pH to between 3.8 and 4.2. The acidity of vinegar, which requires the attachment to be built from corrosion-resistant steel throughout. Mechanical tree spade. The mechanical tree spade is the only front-loader attachment that moves a living organism intact. 3 or 4 curved steel blades, driven by hydraulic cylinders, descend around the trunk of a tree at an angle of 22 to 30 degrees, severing lateral and tap roots as they converge at the base to form a sealed root ball. The tractor then lifts the entire mass, tree, roots, and soil combined, out of the ground. The largest commercial units move trees with trunk diameters up to 10 inches and root balls exceeding 15,000 pounds, the equivalent weight of 3 fully loaded pickup trucks lifted as a single unit. Trees transplanted with the root ball intact survive at rates exceeding 90%. The same tree moved by hand trenching with a burlap-wrapped root ball survives at roughly 50%. Howard Crawford patented a mechanized tree mover in 1961, and the suburban development boom of the following decades created the commercial demand that established the industry. A 3-inch caliper live oak purchased for $300 and installed with a tree spade can be resold as a mature landscape specimen for $1,000. The attachment also serves a conservation function. When construction clears a site, the tree spade can relocate specimens that would otherwise be destroyed, moving them to parks or nursery stock before ground preparation begins.